Okay, our chapter started with parallel lines, skew lines, definitions of all those different alternate interior angles, corresponding angles. So let's take a look at this geometric figure here and identify one pair of skew lines. Remember, skew lines are non-coplanar, non-intersecting lines. So if AH is one of our segments, a line that would be skew to AH would be line FG. That's only one example. If I choose, let's say, DE, we want to know a line skew to DE. Well, how about AB? Non-intersecting and not coplanar. Next, we want to look at the second diagram and we want to find all angles congruent to angle 2. Well, we know that angle 2 is equal to angle 4 because those are vertical angles. Angle 2 is equal to angle 6 if the lines are parallel, because those would be alternate interior angles. And if angle 2 is equal to angle 6, then angle 2 also has to be equal to angle 7, because those are corresponding angles. So we have angle 2 is equal to 4, 6, and 7. Identify all the angles supplementary to angle 6. Well, if we can identify one angle that's supplementary to angle 6, then we can then come up with all of the angles that are equal to that supplementary angle. So I can see first off that angle 6 is supplementary to angle 8. So if angle 6 is supplementary to angle 8, then it must also be supplementary to angle 5 and angle 1 and angle 3, because those are all of the angles that are equal to angle 8. So if it's supplementary to angle 6, it has to be supplementary to the rest. Now let's put a number in there just so we can verify that we understand what we're talking about. So if angle 6 is equal to 60 degrees, that would make angle 8 120 degrees because they form a linear pair, and so they are supplementary. All of the angles that are equal to angle 8, angle 3 would be 120 degrees, angle 1 would be 120 degrees because they're vertical angles, angle 3 and 8 are corresponding, and then angle 5 is also a corresponding angle or a vertical angle with angle 8. So those would be the four angles that are supplementary to angle 6. Okay, same diagram. We are asked if the measure of angle 2 is 84, we need to find the measure of angle 8. If angle 2 is 84, we know that if they're not equal, they have to be supplementary. So angle 2 is 84, which makes angle 6 84, because those are alternate interior angles. Angle 6 and 8 again form a linear pair, so this angle has to be 96 degrees, because 180 minus 84 is 96 degrees. So, angle 8, 96. Okay, the next thing we want to do is we want to use line C, D, and transversal B to identify two pair of alternate interior angles. Well, if we highlight here line B, transversal B, and we want to identify two pair of alternate interior angles. If I have angle 7 as my first alternate interior angle, the alternate interior angle to that would be angle 11. One other pair, if angle 8 is the one I select, angle 8 is here, the alternate interior angle to angle 8 would be angle 9 plus angle 10, using angle addition postulate. For pairs of corresponding angles, corresponding angles are going to be in matching positions off of the transversal. So if I have angle 6, we only want two pair. So angle 6 and angle 11 would be a pair of corresponding angles. And angle, how about if we use angle 5? Angle 5, which angle is corresponding with angle 5? Well, here's angle 5. Matching position off the transversal would be angle 9 plus angle 10. We know that there are four pair of corresponding angles, but here we're only asked to find two. The next thing we need to do is we need to find same side interior angles. Same side interior angles are the same as consecutive interior angles. So they are on the same side of the transversal inside of the lines. So one pair, again we're using only transversal B, angle 8 and angle 11. On the other side of that transversal we will have angle 7 and angle 9 plus angle 10. Okay, next thing I want to review with you is if we have parallel lines and we have to solve for x and x, y, z here, depending on what variables we have in the problem, we need to use our angles formed by these parallel lines in order to help us solve. So in example number 8, these two angles that are marked, 3x plus 10 and 2x minus 15, they are same side interior angles or consecutive interior angles, and those angles are supplementary. So my equation will be 3x plus 10 plus 2x plus 15, or minus 15, is equal to 180. So we have 5x minus 5 equals 180, 5x equals 185, and x is equal 5x equals 185, so x is equal to 185 divided by 5, which equals 37. So x is equal to 37. In example number 9, we're solving for x, y, and z. We have parallel lines here, so this line is parallel to this line. So we can use this transversal, and x would have to be equal to 30 because it's alternate interior with that 30-degree angle. Angle y is going to have to be 80 because it is corresponding with this angle, so using the other line as your transversal. And then for z, let me erase this marking here, we can see angle z and y form a linear pair, so angle z has to be 100 degrees. In example number 10, these lines have to be parallel in order for us to solve. That angle 7x plus 10 and 3x, those are consecutive interior angles, so they are supplementary. So we have the equation 7x plus 10 plus 3x is equal to 180. So then solving that quickly here, we got 10x equals 170, x is equal to 17. We are only asked to solve for x, but imagine if we had to solve for the measures of the angles. This angle is going to be 3 times 17, or 51 degrees. In the angle up here, we're going to take 7 times 17 plus 10, or I can just subtract 51 from 180 since I know those have to be supplementary, and that is going to be easier. We get 129 degrees. Okay, look at these great diagrams here. We have to decide which lines are parallel given that information. If angle 1 is equal to angle 11, which lines would be parallel? Well, those are corresponding angles formed by line ME and line AO. Transversal would be line segment ML. So these are the lines that are parallel given that angle 1 is equal to angle 8. Angle 2 and angle 6, if I mark those angles here, angle 2 and angle 6, those are alternate interior angles formed by line AE, line LO, and the transversal would be AO. Next one, if angle 1 is equal to angle 7, angle 1 equals angle 7. Those look like, if we use AO as our transversal again, they look like they are alternate interior angles formed by line segment ML parallel to line segment ES. So again, let me see if I have a highlighter here. Oh, I have this cool little thing. This line, and this is your transversal. So that forms that angle and that angle. Again, this line, and transversal AO. Next one. Okay, I'm going to use the other diagram on the right here to solve the next one. It says if angles 9 plus 10, angle 9 plus 10 is equal to angle 8 plus 6, if those two angles are equal, which lines would be parallel given that information? Well, if I use this line, and I use ES as my transversal, what types of angles would those be? That would be ME, AO, and ES. And so here we have angle 9 plus 10, and here we have angle 6 plus 8. So those are corresponding angles formed by ME parallel to AO. Transversal would be ES. Next one, if angle 1 plus 2, let's see, 1 plus 2 plus 4 equals 180. 1 plus 2 plus 4. Here's 1 plus 2, and here's angle 4. So if that angle plus this angle equals 180, which lines would be parallel? Well, those appear to be consecutive interior angles formed by line AE parallel to line LO using transversal ML. So let's use our cool little tool here. If I use this line, and this transversal, I have those two angles formed. So this line, and this transversal. Okay, now for your favorite part, this is where we're going to prove that lines are parallel. So our goal here is to prove that LT is parallel to AN. Well, we know that we have a few different ways to prove that lines are parallel. If we can show that alternate interior angles are equal, that'll do it. If we can show corresponding angles are equal, if we can show same side or supplementary. Those are just three of the ways. So looking at what's given, we want to prove that LT is parallel to AN. Again, I want to make a plan, so I'm going to make my little thinking cloud. If I can show that angle 2 is equal to angle 3, that will prove that my lines are parallel because 2 and 3 are alternate interior angles formed by those lines LT and AN. So let's write the given. LT bisects angle PLN, and angle 1 equals angle 3. So we write the given, then we got to use the given. So here's angle PLN. PLN is right there. So if LT bisects that angle, which angles have to be equal by definition of angle bisector? Angle 1 has to be equal to angle 2. Definition angle bisector. Because a bisector does cut an angle in half. So now we've used the given information. We're also given that 1 equals 3. So what else? Nothing else I can get from the diagram. So now I have to look to my statements and see if I can make any conclusions. Well, since angle 1 equals 3 and angle 1 equals angle 2, I can say that angle 2 is equal to angle 3 by the substitution method. I can replace angle 1 in that first equation with the value angle 2. So that is substitution. Or I could use if angle 3 is equal to angle 1 and angle 1 equals angle 2, then I know 3 is equal to 2 by the transitive property, but I think this way it's easier to write just substitution. And then the fourth step, since we showed what's in our thinking cloud now, we showed that 2 equals 3, we know that LT is parallel to AN, and the reason is because if alternate interior angles are equal, the lines are parallel. And you're done.